Alright guys, in section 11.4 what we're going to be talking about is going to be all about what are called congruent arcs. And we're going to talk about some of the properties that congruent arcs have, and then also talk about some of the properties of chords. So first of all, we say that two arcs are congruent when, number one, the arcs have the same measure. So the arcs have to be the exact same measure in order to be considered congruent. In other words, looking at this circle that we've got with center P, if we knew the measure of arc AB was, let's say, 50 degrees, and the measure of arc CD was 50 degrees, then we would say that arc AB is congruent to arc CD. Okay, so that's one way we can say arcs are congruent. We could also say they are congruent if the central angles are congruent. So if we, let's say, didn't know the measure of the arcs, but knew the measure of the angles, and these two angles were congruent, then once again we could say that arc AB was congruent to arc CD. The final way that we can say that two arcs are congruent is if the chords which are shared are congruent. In other words, if we knew that this chord AB was congruent to this chord DC, in other words, if we could say that AB is congruent to CD, then we could also say that the arcs which contain them, so arc AB, is congruent to arc CD. Oops. So lots of different ways that we could say that arcs are congruent. Okay, so let's use that information to solve for some variables. Starting with example A here. So we've got our circle, we've got our two chords. Let's figure out what the measure of this missing piece is over here. And to find that, what we'll do is we'll take 360 minus the two arcs that we do know, so minus 220, and then minus 70. And when we do that, we find out that the measure of the missing arc is also 70, which means our two arcs are congruent, 70 and 70. That means that our two chords are congruent. In other words, 12 and x are the same. In other words, x equals 12. Okay, for example B here, we were told that IJ is 10 centimeters and HA is 11 centimeters. So let's do the same thing we did in example A. Let's find the measure of this missing arc from from K to A. So we'll take 360 minus the arcs that we do know, so minus 140, minus 55, minus 25, and minus 60. And after we do all of that, we'll find out that the measure of that arc is 80 degrees, which actually is going to be the same as one of our other arcs. If we put together the distance from I to H with the distance from H to J, 55 plus 25 is 80 degrees as well. And so that means that if this is 10 centimeters, that this right here is also 10 centimeters. That's actually what we were looking for, which is AK. So AK is 10 centimeters. All right. In many of these examples, we're going to be continuing to kind of do the same thing. So once again on C, we're going to try to find the measure of this missing arc right here. So we'll take 360 minus the other arc, so minus 113, minus 91, and then minus 78. And after we subtract all of those numbers, we will get 78. So that would be the measure of this right here. So now notice that you've got your arcs that are the same. You've got 78 and 78. That means that the two chords would have to be the same. So 9 and x would have to be the same. So x would be 9 centimeters. All right. For example D, we're not given as much information, but we can use what we're given to still solve for our variable. Notice that our chords are all the same, that they are all congruent to each other. What that means is that the arcs all have to be the same. So if one of them was x up here, then the other two would have to be x as well. So what we'll do is we'll take 360 degrees minus the 27 that we know. That leaves us 333 to be divided between the three arcs. And since they all have to be the same, we'll just take 333 and divide by 3. That gives us 111 degrees for each of those arcs that we were looking for. And so that would be our value for x, would have to be 111 degrees. All right. In this next example, we're going to go ahead and continue to kind of do the same thing. Once again, we're looking for some variables. We've got x that we're looking for on these two segments, and then we've got some other additional segments, which I'm just going to call another variable. We'll just call them y for right now. And notice that we've got a diameter in the middle of our circle that's splitting it up into two sections. Remember that each section then has to add to be 180 degrees. So let's start with the section on the left. If we take 180 degrees minus the 88 that we know, that's 92 degrees that's left over. And that 92 degrees has to be split evenly between our two sections that we do not know. So if we take 92 and divide by 2, that gives us 46. In other words, each of these y's is 46 degrees. I'm going to go ahead and just write that in place of that variable. So then we're going to do the exact same thing on the other half of our circle. We're going to take this time 180 minus that 46 that we just found, which is 134. And then once again, we're going to divide that by the two sections that we need to find. And 132 divided by 2 is going to be, or 134 rather, divided by 2 is going to be 67. That's going to be our measure for x in both of these places. And there is our answer. All right, so F, why not take an easy one? If we know that these two chords are the same, then our arc lengths have to be the same, or our measure of our arcs have to be the same. So our x would have to be 74 degrees. Kind of a nice, easy one to throw in there. Okay, so the last one on this page of the notes, and then we'll look at our second page with some additional rules. We're asked to find the measure of BC. So we already know that these two chords are the same. That means that our two arcs have to be equal to each other. So what we would want to do is go ahead and set those equal to each other. So 3x plus 11 equals 2x plus 48. And then we can solve for x. So let's go ahead and get all of our variables to one side. I'll subtract 2x from both. That'll leave us with x plus 11 equal to 48. And now to get x by itself, subtract 11 on both sides. And we get that x is equal to 37. Which, while that does give us the variable, that does not give us the measure of arc BC. If we want to find the measure of this arc BC, then we're going to have to use this equation, 2x plus 48. But now we know that x is 37. So we'll take 2 multiplied by 37 plus 48. And when we add those together, we'll go ahead and get 122. There would be the measure of our arc BC. Okay, so some additional properties of chords to talk about. If two chords are the same distance from the center, then the two chords are congruent. In other words, if you knew that the distance right here was the same from P to X as it was to P to W, then you'd be able to say that your chord CD was congruent to your chord AB. So again, if PX was congruent to PW, then we could say that AB is congruent to CD. And then the second property that we'll be using in this second half of the notes is that if the diameter of the circle is perpendicular to a chord, then the diameter bisects the chord and the arc. In other words, if we knew that CD was perpendicular, and for perpendicular we use this symbol, so if we knew that it was perpendicular to AB, then what we'd be able to say is that these two segments were equal to each other. In other words, if we called this some other point, we'll just call it E, then we could say that AE is congruent to BE. So we can use that information to work through these problems. Let's take a look at our first example. And we're asked to find the length of the radius. So what we're asked to find is this distance right here, which makes kind of a right triangle. In fact, we're going to use that right triangle to help us solve. Now, since we have a right angle, we can say that these two segments are the same, that AB, or from A to this center point, and then from B to that center point is the same. So if we take 5 and divide by 2, that's 2.5 for each of these segments. So we want to find this missing length. We'll go ahead and call that C. Since we're going to use the Pythagorean theorem, we're going to let A be 2.5, B be equal to 2. So when we use A squared plus B squared equal to C squared, A squared is 2.5 squared plus B squared is 2 squared, and that's going to be equal to our missing side, C squared. So 2.5 squared is 6.25 plus 2 squared is 4, still equals C squared. When you add those together, we'll get 10.25 equals C squared. So then we'll go ahead and take the square root of both sides. So we'll get that C is equal to the square root of 10.25, which then as a decimal is about 3.2, and there is going to be our answer. Okay, so we're going to do pretty much the same thing on this next example. Once again, we're looking for this distance from A to C. We've got our right angle, and we know that 3 centimeters is our one side. In fact, we're told that it's congruent to this other side, so both of those would have to be 3, and once again, we're looking for C. So then we'll go ahead and once again use Pythagorean theorem. And since they're both the same, it really doesn't matter, but we'll just go ahead and label them as A and B. So that would be 3 squared plus 3 squared equals C squared. 3 squared is 9, plus 3 squared is also 9, and that's going to be equal to C squared. So then add those together, 18 equals C squared. And now we'll go ahead and take the square root. So we'll take the square root of 18, which is approximately 4.2, and there would be our distance C. Okay, so a few last examples to take a look at, and then that should be it for today. So as to find the value of x, we're told that these two sides are congruent. That means that we also could say that our arcs are congruent, and that means that these two lengths are congruent. And so that means that if this is 5 centimeters, that this is 5 centimeters. That also means that this, which is where x is also 5 centimeters. So pretty easy for this one to solve for x. It's just going to be equal to 5. All right. In this next example, we're going to go ahead and solve for x. We already know a couple of the sides. We know 5 centimeters is this side of this right triangle that we're going to be looking at. And if the entire diameter is 20, take 20 and divide by 2 is 10. So that means that one of our side lengths is 10. So we're going to once again use Pythagorean theorem. This time 10 is our C value. We can let A be 5, and let's let B be x. So setting up our Pythagorean theorem, we'll take a squared, which is 5 squared, plus b squared, which is x squared, and set that equal to c squared, which is 10 squared. So then 5 squared is 25, plus x squared is equal to 10 squared, which is 100. So then we'll go ahead and subtract 25 from both sides. We'll get that x squared is equal to 75. So then we'll go ahead and take the square root. So x is equal to the square root of 75, which we can actually simplify that a little bit. Since 75 is divisible by 25, we can rewrite that as the square root of 25 multiplied by the square root of 3. And the square root of 25 is 5 multiplied by that square root of 3. Here would be the exact answer. If you were asked for a decimal approximation, then you would just type that into a calculator, and the square root of 75 is approximately 8.7. So depending on if they wanted you to leave your answer exact or just get a decimal approximation, you could use one of those two answers. Okay, so one last problem that we're going to take a look at here, we're going to look for x in this particular problem. So if we know that our radius is 6 centimeters, then if we were to connect these 2 points, this would also have to be 6 centimeters. So then what we can do is we can use that right triangle to then solve for the missing side, which again, we don't know what that is. We can't use x, so let's just call it y. So then we can say that a is equal to y, b is equal to 3, and c is equal to 6. So let's go ahead and set up our Pythagorean theorem one last time. So we would take y squared plus 3 squared and set that equal to 6 squared. So then we would simplify y squared plus 9 equals 36. Go ahead and subtract 9 from both sides. So y squared equals 27. And then go ahead and take square root. And this time, once again, we can go ahead and simplify that a little bit. It's divisible by 9. And then we can go ahead and say that that is 3 times the square root of 3. Now, while that gives us y, that doesn't give us x. Notice that x would have to be basically double whatever we got for y. So for x, take what we got from y and multiply that by 2. And that would become 6 multiplied by the square root of 3. So once again, here is your exact answer. If they wanted you to write it as a decimal, then what we would do is type it into a calculator to find out that x is about 10.4. All right, guys, that is it for this section of the notes. We will look at inscribed angles in section 11.5. Until then, have a great rest of your day.